going to change my layout as well. There we go. Okay, so I'm going to go ahead and share my screen, and we're going to just go over the teacher account first. And there we go. And then we'll pass it over to Christine and get started with circuits. All right, can everybody see my dashboard in Tinkercad? Give me a little thumbs up or an okay in the chat.
Looks good.
Looks good. All right. So I'm already logged into my account, and I know that I have a teacher account because up in the menu up top, I can see classes. And if you already have a Tinkercad account yourself and you don't see this option, that means that your account isn't identified as an educator account. Is quick fix. If you go into, click on your profile up in the top right corner, and you go to your settings. Just down here in your profile, it says, how will you use Tinkercad? The drop-down menu is there. You just choose your role as teacher, save the changes to your account, and then when you refresh your page, you should see classes here at the top. So, and then when you go to sign up for Tinkercad, if you go to tinkercad.com and you click on create an account, it'll also ask then when you're creating it, what type of account you'd like to create. But if you already have an account created and you want to switch it over, it's just a matter of going into your profile and selecting your role. Now, as an educator, once you have your teacher account and you see classes up here on the top, you can click on that, and it's here that you can manage your classes. So some of the reasons why you would want to do this is because you can add students to your roster. And once they're added, you'll be able to see the projects that they're working on. So if you assign them a design project or you assign them a circuit project, you'll be able to see their work and open it up and have a look at it with them, or have a look at it afterwards for grading purposes, instead of them creating their own account and then having to send you the link to their project. So just great online classroom management. And you can see down here that I already have my class created. And it says how many students that I have in it. If I wanted to go ahead and make another class, I can just click on create new class. Now, because I'm sharing a tab, I'm assuming you're not seeing my pop-up, hey?
No, it's working.
No.
Oh, good.
Yeah, it's working.
Okay. I find sometimes, depending, certain pop-ups don't show up when you're presenting, so just making sure you can see everything. So you can go ahead and enter your class name. You can also pick your grade level, your age range. You can put in your subject if you wish. And then all you have to do is go ahead and click on create class. And that creates a class for you down here. In order to add students or manage it, you want to go ahead and click on that class that you created. And right now my classroom is empty. And there are a few ways that we can get our students to join our class. So depending on the age of your student, you might want to go about it a few different ways. If you have older students, junior, senior, high, you can have them go ahead and create a Tinkercad account with Google, because their Google accounts are compatible with Tinkercad. So like many sites we see now, when they go to create an account, they can just click on login with Google. And if they're on their Chromebook or they're logged into their Chrome browser, they can just log in right away, just clicking on that option. Another option is to add your students and give them nicknames. So if you have younger students and you don't want them to disclose any personal information, or they're under 13, then you can go ahead and add students by clicking here, and you can type in their name. For me, I just put in their first name and their first initial, and you can assign them a nickname. And that way they don't need a password, which is handy, and they just need to remember their nickname, and you don't need to put in their full name. So it eliminates them having to create a password and for them having to give up personal information. So I just named mine first name, first initial, and I just named them Viper 1, Viper 2, Viper 3, Viper 4, super simple. And that's our mascot. And I added them all individually like that. Now, of course, that'll take a few minutes, but for me, that was convenient. And then you save your changes. And when you go back to your class list will be populated. From there, you can either share your class code. So that's a series of letters. And when students go to tinkercad.com and click on login, they'll see the option to log in as a student, and they can enter their class code, which is what I have displayed here. Or, so I can copy that code, paste it in our Google Classroom so they have access. Or I can copy this link, and this link is unique to my class, so this Tinkercad Classroom, and this is what I did. So my students, these are the instructions I gave my students. I gave them the link, I pasted it in our Google Classroom, I told them what their nickname was, and they clicked on that link, typed in their nickname, and they're right in Tinkercad. They didn't need a password, and they don't need to use their Google account. They can also go to Tinkercad, type in our class code, which is up here, and log in with their nickname that way as well. Alternatively, like I said, if you have older students and they can use their Google accounts to log in, again, you would copy this link, and you can put it in your Google Classroom. They can click on that and select the option log in through Google. So again, class code, class link, you can allow them to sign in with Google, or you can assign them nicknames and they can log in that way. Any questions on adding students or sharing the link or code? All good? And again, some benefits of this, and I'll just click on my class real quick. Some benefits of this is there's my class list populated. I can click on designs and I can see everything that my students have been working on. Very quick access. I can also see their activity, when they last logged in and what project they were working on. And something else that's nice, and this is by default, when you create a class, they're on safety mode. So that doesn't allow them to have a public profile, limits comments. It gives you a few safety options there if you want to look up about safe mode in Tinkercad. If you do a quick Google search on that, it'll list all the safety options there. But you can turn that off. But like I said, it is on by default, and it just creates a more safe account. It's not as public, widely open to the public. So, and that's because it is a class account. So again, if you have a teacher account, you can create a class, you can manage your classes, you can view your student projects, and you can also assign lessons. Tinkercad has a lot of pre-made lessons that you can assign as well. And I think, Christine, are you gonna chat about the lessons a little later?
Sorry, if we have time.
Okay. Yeah, so I'll leave it there. Tinkercad does have a lot of pre-made lessons. If you do a quick search, you'll see them. And if you have a class created, you will be able to view those lessons.
Yeah, so Andrea had a question.
View and assign, sorry. So that's a really great option as well. So you're not totally starting from scratch. If you're a little intimidated of, okay, what project can I give my students? There are a lot there, including ones on circuits. So we're all good with student and teacher accounts. I'm going to turn that over to you, Christine.
Hold on. Now, Andrea just wanted a clarification about how do you get a class again. So you had to go to settings and change your role.
Yeah, so if you already have a Tinkercad account and you don't see the option classes up top here, then you're gonna want to go to your profile settings and make sure that your role is set as a teacher. If you don't have a teacher account, you're not going to have the option to create classes. So make sure you have that switched over first. And then once you do have the option classes, it's just a matter of going to the classes option and clicking create new class.
So I clicked profile, but what comes up when I clicked profile is gallery, blog, learn, teach, and then the search menu and where my profile picture would go.
Yeah, so you click on your little profile picture.
And then
go to profile.
New. Okay.
No, go right down to profile with the little gear.
Yeah, and that's what comes up, the gallery, blog, and all that stuff.
Yep. Yeah, okay. And can you scroll down?
Okay, I see it now.
There you go. So click teacher, save your changes, and you might also want to refresh your page before the classes option shows up.
Okay, thank you.
No problem. All good?
Yep, that was the only question.
Okay, well, I'll stop presenting and I'll turn it over to you.
Sure, and I'll present now.
Okay.
Hopefully. So I can see my screen. Hopefully everybody else can as well.
Yeah, all good.
All good. So this is sort of what I was thinking in terms of how it would flow here today. And I'm hoping to be able to get to the end, depending on the amount of time. So just a kind of a general overview, then we'll just look at a simple circuit and then introduce the breadboard. Some people may not have experience using a breadboard, then looking at the microbit and a little bit of coding, and then the Arduino and how you can use all of that within Tinkercad Circuits and simulate anything that you create, which is pretty useful. So what I have here is a lot of people say, well, why Tinkercad Circuits? There's a lot of different reasons. And basically the biggest reason, I'm not going to read all this out, but the basic reason that I see is you have an electronics lab already established for you where students can tinker, they can put different things in their circuit, and there's absolutely no need and no worry about what's going to go missing, what's going to potentially be, become broken or blown or whatever the case may be. Whatever ideas come to their heads, they can just try and see what happens. So, which is really, really good. And the simulation aspect in Tinkercad Circuits is good as well. They are very in-depth with the Arduino and the lessons, and they're getting a little bit better at having more content with the microbit and the lessons that are there with the microbit as well. So there's a lot of things. You could just use simple circuits, and then you can progress simple circuits with the breadboard, and then progress, introduce the microbit, and then progress and introduce the Arduino with programming. So it's good entry points for a lot of different variety of skills. So sharing with students, I'm not going to go over this, but you can share anything that, say, you create. So if you wanted to create a circuit or a program, and you wanted to share that with the students so they can go in and tinker around and see what happens when they replace different parts of the circuit, that's certainly possible as well. So I just put that there. So a lot of people ask, can I share anything that I create with my students so they can go in and tinker around with it? You certainly can. So I just have that there, and I'm pretty well sure that, Megan, this presentation will probably be shared with everybody.
Yeah, I can definitely email this one out afterwards for sure.
Okay, yeah. So if you want to to see that blog there, it talks about it, and it's pretty straightforward. So this is the Tinkercad sort of platform, as you see here. And over on the side, I have it highlighted there in purple, but over on the side, it will say, I think, 3D design, circuit, code block, and lessons. So obviously, if we were going to do some 3D printing, 3D design, we would obviously choose the 3D design, the first option. The second option is what we're going to be looking at here today when we're going to create circuits. So it's just, again, the exact same, I guess, website that Megan just talked about, the tinkercad.com. You go there and just, instead of selecting the 3D design option, you would just select the circuits option. And this is what your dashboard would look like. So it does have a lot of lessons and a lot of different examples and everything there. All of these that I have here is just me tinkering around with a lot of different things, with a lot of different circuits. So that's what you see on my dashboard. Your dashboard, if you've never created a circuit, will have nothing there besides that kind of green button that says create new circuit. So every time you create something in Tinkercad, the beauty of it is it automatically saves for you. So you don't need to worry about, is it saved? Anything like that. It will save it for you automatically, and it becomes part of your dashboard, which is excellent. So if at any point in time, Megan, if there's any questions, just pipe up, and I'll certainly try to help. This right here, there is, and again, this link brings you to the starters, lessons, and projects. They have so many things here. So if you look at this right here is just all on circuits, and it's very sequential. So if you just wanted to start simulating, they have a very simple circuit here, and you can click on that, and it goes through how do you actually go about creating this circuit? How do you go about simulating? It has step-by-step instructions. So it's very sequential, very easy for you to actually go about with any of this, and you say you want it to start a particular circuit, or if you want it to start, say, hey, I want to introduce breadboarding. What is that? So there's starters, there's lessons, and there's projects. So it's very, I guess, well laid out, and there's a lot of work gone into this, and there's a lot of things that your students could potentially go to right away, and you know, kind of have it self-directed and then be able to go through it on their own. So right now, what I'm going to do is let's just create something. Let's go to tinkercad.com and create a very simple thing that you see here. And for those who are in grade 6, the grade 6 teachers out there, if you had the professional learning opportunity, I believe it was 2 years ago from Brilliant Labs, this is basically what we created. We created, but we used a microbit, and we'll do that hopefully maybe in like 5 minutes or 10 minutes or so when we get to microbits. But this is simply, you know, the design that we had. We had a battery, and we connect it to an LED, and in this case, I put a resistor in. So what I want, hopefully, is you'll be able to go to tinkercad.com, and I'm going to go through the different features of Tinkercad so that we can see how to actually create something like this. There's so many different options here just in creating this small little circuit. So I'm just going to go through some things here. As you can see, right, I have some things annotated here. And to put anything here, so if you create a diagram, you want to share it with your students, and you want to have a little bit of explanation, you can just go up here and click on this, and anywhere here now that you click, you can annotate. So that means you can just write your note here and tell your students what you want them to know. Now, if at any point in time these annotations got a little bit overwhelming, you can actually hide them as well by just clicking on that little eye, and it gets rid of all those annotations. So that's very useful as well, because sometimes it can get a little bit overwhelming if there is too much on the screen. So what I'm going to do now, I'm just going to really quickly show you some of the features that Tinkercad has here, just in recreating this simple circuit. So I'm going to go up right here, and I'm just going to click on this zoom to fit, and you see it sort of like, you know, recenters or, you know, realigns your whole circuit. So all I'm going to do is over on the side here, there's different components. You can choose different things here. There's the basic components. Maybe that's where students want to start. You can go to all. So everything that Tinkercad has here, it could be distance sensors, motion sensors, it could be potentiometers, a lot of different things that you may not be familiar with. Different size breadboards, all of that will be found under all. But right now, I'm just going to stick with basic. So because we're starting from scratch. So I'm just going to stick with basic, and I can go over and choose the coin cell battery. So all I'm going to do is just take this, drag it over, and drop it. I'm just going to recreate this particular circuit that you see here. So it actually gives it gives you the ability to rename any of your components. So right now, the name on this is coin cell battery 2. So it's a 3-volt battery. You can name it something different if you want. I'm just going to leave it at the default. And again, you could pick different batteries. I could have picked a 9-volt battery if I needed something with more power. I could pick 1.5-volt batteries here and actually select how many of those I want. I can have 2, 3, 4. So that option is there. So anything that you choose to use over here, all you have to do is take it and drag it over. And again, you can change the color of it if you really wanted to using this drop-down menu. I'm just going to leave it as red. Your resistor, typically resistors, what they do, they help prevent, I guess, your LED from having too much current passing through it. Right now, the default resistance would be 1 kilo ohm, and typically for an LED, I would think like 100 ohms and would be perfectly fine, but you could have just left that at the default value if you wanted to. So I'll just change that to 100. Now, if I want to connect these together, so looking at this right here, if you click on any element and you don't like the way it's oriented, you can come up here and you can rotate it. So that's your little rotate feature here. So you click on any item, you don't like the way it looks, you can just rotate it all the way around. Now, I like using quick keys. The quick key for rotate is just R. So if on my keypad now, I'm just hitting R and I rotate it really quickly. So all I would need to do now is to basically connect my components. So right here, as you can see, if I'm going to recreate this, I'm just going to rotate this around. So I want it to look exactly the same. I'm just going to recreate it. So right now we see that here, that's my negative end. I'm going to connect it. And if I just click on that, it will start automatically with a wire for me. Now, I can just go directly to the cathode here, or if you want to think about, if you've ever seen an LED, that is the, whoops, sorry, that's the short end of your LED. And how you actually hook up your LED or connect your LED is important because it does have polarity. So if we connect it the wrong way, it won't work when we simulate it, but if we connect it the right way, it will work. So right now I know that this negative end has to connect here to that, I guess that's going to be the shorter leg in your actual LED, but it's the straight leg in the simulation here. I could just connect it here, but if I didn't like that and I really wanted to have a different like sort of path, all I would do is click here, and I can, every time I click, I can change the direction of the wire and then connect it up like that. So if I didn't like that, all I have to do then is take my mouse, click on any one of these, and I can reorient how the wire is actually placed. Now, this is coming out of the negative terminal. I'm going to make it black. That's sort of how I like to arrange my different colors here. And if I really wanted to, and students really wanted to, they can actually make this into an alligator clip, which is something that they probably will want to do. And you can reposition your alligator clips around here. If I can actually get a hold of it, here we are. I can reposition my alligator clips and use something different. So you should be able to take them. It's going to take a little bit of finessing, but you can kind of orient them. I'm just going to go back to the straight wires. And we would just connect it here to there. And again, if I want to change directions, just click and you can change your directions. I'm going to make that one red. And I have a circuit. Now, if I want to simulate this circuit, I would just have to go over here and click on the Start Simulation. Or the quick key would just be hitting the S on your keyboard. So if I start the simulation, I should see, yes, in fact, that my LEDs do in fact light up. And there's a simulation timer here as well. Now you can test it out without the resistor. And if you do that, so if I want to edit, I need to stop the simulation. And if I wanted to remove anything, I would just click on it and hit either the trash can up here, or I can just hit the delete and it will get rid of that. Now, just watch what happens, and I'll make this black. When I start my simulation without the resistor, it's actually telling me here, and it gives me a kind of like an eye, that the current going through that LED is a little bit too much. Now, I know this is a good conversation to have between your whole theoretical versus experimental. In theory, it's telling me it will blow, but if I actually do this experimentally, here is coin cell battery, here's my LED, and there's probably, you know, the current's going through it is not actually causing the LED to actually pop or blow, but in this case, it's telling me that a resistor would be the best way to go. And certainly, you know, that's something that they can test out as well. But here it's telling me that it would actually go, but I know just from based on some of the circuits that I've been doing that, you know, that's not going to happen here. But it's still good practice to push a resistor in between just in case. So I'm going to stop the simulation. So the good thing here, you can actually come over here and click on this little icon, because if there's any of these basic components that students aren't aware of and they're like, hey, what's that? What is a potentiometer? That sounds interesting. I'd like to know. You can click on this and it will give you a description of what each of the components are, which is pretty useful. And the other thing is I can just click on that again. It just goes back to the pictures. The other aspect that I really found interesting is if I wanted to make this circuit in real life, I can actually click on this component up right here that says component list. So click on that option. It will actually allow you to see what you need in terms of quantities, in terms of your LEDs, your batteries, and things like that. So students don't have to remember what was in that circuit again. And they can download it as a CSV, which just would be able to be open in Google Sheets or PowerPoint. What's this? Excel, sorry. So you can download it so you get an actual list that you're able to copy or print off so that you can see what you need in order to be able to create that circuit I guess, in real life. So that's pretty interesting as well. So that is just that simple little, I guess, circuit that we sort of recreated. All you need to do is just take the components that you want and connect them together. And if I did connect them up incorrectly, seeing that the LED is polar and it's important how you connect them, when you start your simulation, the LED just would not turn on. So it's a pretty good situation in which students can put things together and not have to worry about doing any damage or anything like that. So that is some of the, I guess, things here. If there was a programmable part to this option right here, this is what we would click on to actually do any of the coding. And that's what we'll hopefully be able to get to in the next few minutes. So with that, was there any questions or anything, Megan, that needed to be addressed?
Yeah, Annette is asking, can each student in the class see each other's work? So
you can actually go up here to the share button, and you can take a snapshot of your design and share it with your students, or you can actually invite people. So you can invite people to actually go in to this design, and they can view and make changes to your design. So that's how you would share it, and then be able to, you know, go on and kind of collaborate on the same design if you wanted to.
similar to if you created a Google Doc or Google Slides, you can add people to your document and work on it collaboratively in real time. You can do that with Tinkercad Circuits as well as the 3D design part. Students can't look at the dashboard and see all of their peers and all of their peers' projects, though. That's something that only teachers have. So if students were collaborating on something or wanted to share their project with a peer, they would have to do what Christine just did and click on the share button. And again, they could download their project, or they could get when you click on share, you can get a link. So they would get their shareable link, and they would then have to message that link to or email that link or what have you to the person they wanted to share their project with. It's not like you're adding the user to your project. You're sharing it with them through a shareable link. And that link doesn't last forever. I can't remember the lifespan of the
I think
link.
it's like 36 hours.
Something, yeah. So they, after a few days, they might have to go and share the link again. And it would have to come from whoever created the file to begin with. So if they're doing group work and you have 3 people in on it, one person would have to create the project, get the sharing link, and send that to their group members. And when the link times out, they would have to get the sharing link again. But there's always one owner to it.
Yeah.
And
sure.
everybody, yeah. So if you give a sharing link, they will be able to tinker with it then. Yeah, they'll be able to edit it together.
Yeah, and if you didn't like any, like, you know, if a student wanted to use this type of battery, again, I just want to show this, you can change how many batteries you had. You can change whether they're AA or AAA. You can have a built-in switch on your battery if you didn't want to have a switch external to this. So there's a lot of different options here, and it's just a matter of playing around. They can recreate this circuit, but not have the coin cell battery, and it look completely different.
Yeah. Another question in the chat, Rod was asking, where was it that you clicked to see the components you used? So
you come over, you come over here, and so if you hover over this says that's your circuit view, and this is your components view. So you just click on that, and it gives you a list of all your components, and then underneath that, you can download it as a comma separated value kind of file, which is just, you can open up as a spreadsheet.
So if you did want you to get your students, say if you are teaching remotely, or if you just wanted to get them to kind of do their blueprints this way, design it this way, and then try it in real life after, they could go in, design their circuit, they could download their spreadsheet so that they have the list of all the materials that they need. So then the next time they're in the classroom or in the lab, they can take that list of materials and go get the physical components and then build it in real life. So the two really mesh together really nicely.
So this export button I didn't really talk about. This export button is not really going to be 100%. Maybe it could be, I don't know, but it's not going to be really 100% applicable to most people. It's a .brd file, and what it basically does, it downloads a file that you have to open in another piece of software that gives you like a schematic of the actual circuitry. So if you want to see, in my head, I always liken it to you have buildings in 3 dimension, but then you have the architectural blueprints. It's like a circuitry blueprint. So you see your schematic of your actual diagram. So You would need another piece of software that actually opens up the .brd files.
Yeah.
So that's what
And like you said earlier, Christine, like there's so many different entry points to this. I mean, this can be applicable in elementary science, and it can go right up through to senior high. So it really depends on where your students are at and what your needs are, but there are so many different ways that you could be using this.
So we just created a very simple circuit and got to see how we can change the wires, the resistors. You can change the color LEDs. There's so many different components here. I'm not really going to go beyond these components. I just wanted to keep the circuitry simple, but look at some of the aspects of Tinkercad Circuits itself. So the next thing is this one. Let's create a breadboard. So we have the exact same thing again, but now we're going to actually use the breadboard here. So breadboard is a quick way for students to be able to, say, prototype some circuitry without actually having it to be soldered together. And it's often used a lot of the times, I guess, by maybe, you know, some of the high school courses, and it certainly can be used in grade 9 as well. It just offers that other feature. You wouldn't need alligator clips or anything like that. So I'm going to recreate this right here. And basic, I'm going to stay with the basic again. Under the basic, you take out the exact same things that we took out before, but in this case, we're going to use a smaller breadboard. And for me, I can honestly say I have this spatial challenge. I really, truly do. I remember the first time I saw this, I was kind of like, what's connected to what? If you hover over, these are called your power rails. So if you look at hover over it, hopefully you can see that everything kind of lights up or in green. That means every one of those connectors or every one of those positions are connected, and they are represented by the negative side of your battery. This one right here, this is where, obviously there's a positive right here. This is where you will connect the positive side of your battery. And every one of these potential positions here is connected to the positive side of your battery. Now, what I always do is I connect the positive here to the power rails down here, the positive here, and the negative here to the negative here. So just in case, so that students can either use the top power rail or the bottom power rail because they're both connected to the battery. So that's what, I guess, the top and the bottom. And then the inside here is where you would put your components. And if you hover over this, you can see that this leg right here, every single one of those particular holes, there got to be some technical term besides holes, but every one of those positions are connected. So that's telling me that the leg here of this LED is connected to this black wire. So if I scroll down through this black wire is then connected to this right here, which is obviously connected to the negative terminal of my battery. And so what it basically does is it allows you to see that, you know, I like the fact that you can hover over it and see what's connected and see how the actual circuit is being established here. So as you see, this is my negative, which is also down here, and I can travel, come up here, see that this is connected, and through my LED tells me that this right here, if I hover over it, is connected now to that terminal of my resistor. Go across my resistor. This terminal of the resistor is connected to the red wire, which is then connected to the positive terminal of your battery. So a breadboard is just a way for you able to, you know, prototype without having the permanency to it and without having all the wires all over the place. Because if you ever taught, I guess, electricity before, the amount of wires sometimes with alligator clips going all over the place, it truly can get confusing. But this is a really good way of simulating, I guess, your circuit. And here, there are no programmable parts to it, so I'm not going to click on the code, but if I actually click on the start simulation, hopefully if I have this connected correctly, my light will turn on, and it does. So looking at a breadboard and connecting things, you're looking at it, I'm always like, what's connected to what? And what, like, I have spatial problems, I really do. But when I was using this here and being able to see what's connected to what, it just helped with the whole visualization and setting up your circuit. So I'm going to stop that simulation. So hopefully, I know I'm probably going over this super quick, but hopefully you get to see how to actually recreate this. Again, just bring over your breadboard, and I'm just going to come up here. As soon as I add something new, I can just click on zoom to fit and it reorients it for me. And right alongside of it, I'm just going to move this over. I can now, or down below, I can now recreate this and see if I can actually go through the process of setting this circuit up properly using the breadboard, which is pretty neat. So any questions?
Nothing in the chat. Anybody need any help with anything? Any questions? Nope.
No? Okay, so now we can actually go, I guess, and look at adding a programmable component to it, like the microbit. So I'm not going to read this, but basically the microbit, hopefully people are familiar with the microbit. I know we've been working with the microbit now for a significant period of time, and hopefully you've at least seen the microbit. It has a lot of sensors on it. The BBC actually, or microbit actually calls it a pocket-sized computer. It's actually a microcontroller, but I'll leave it at that for right now. It has the ability to connect to lights, sensors. It has sensors on it. It has a temperature sensor, a motion sensor like an accelerometer that's able to detect motion. You can get it to do certain things when you press button A, or when you press button B, or when you press both. So there's a lot of different things that you can do with this, and I'm hopefully hoping that some people have experience with it, because you could spend the entire session just on the microbit itself. So,
Christine, I'm just going to jump in real quick. Annette did have a question in the chat after. Can you simulate how long it will take for your battery to run down? As far, I don't know. I've never tried it. I'm going to assume that the battery will just live forever in the simulation, but that's a good thing to try out. I don't know.
It is, yeah. Like, I've not come across that. I guess the simulation, like, I'm thinking the simulation would just have it go on, like you say, forever. But I guess that would be a little bit of grade 9 science there, using the Ohm's law and probably trying to figure it out. Maybe, I don't really know. Yeah.
Yeah. Something to
I
try
haven't
out.
seen that one. Something to try out for sure. Yeah.
Just quick check in the chat. How many people have had experience with microbit? Do you have some at school with you? Have you tried it before in a workshop? Have you tried it with your students? Yeah, we got a few people there.
We get a few.
Awesome. Oh, lots of people. Good. So
good.
you all know how awesome it is and all the cool stuff it can do. So it's great to have another way to use the microbit with circuits. Again, if you don't have all the physical components in class with you, you can do this online as well.
Certainly. And I hate to gloss over the microbit, because I think it's like super useful. But I know that this session is not necessarily on the microbit. It's about the the Tinkercad circuits. But we could spend so much time just on the microbit. Is not funny. But I just want to point out that there is version 1 and version 2, or I think it's version 1.5 actually, and version 2. So the most of the stuff in Tinkercad is compatible with version 1. They haven't got the updated blocks of code yet for like different things, like with the microphone input or the speaker or anything out there. But I know that they're working on it. I've seen upgrades already to their microbit from just from last week to this week. So I'm sure that they're going to integrate those certainly soon, because like I said, it's constantly being updated. But that's just the different versions that you can have. And basically, I like doing this. And the reason I like doing this particular example is, if you look at the example here on the left, that's basically grade 6 science. So without the resistor, but I put the resistor in, but without the resistor was grade 6 science. Code the microbit, then on button A, you set the pin to high, the light goes on. And when you hit button B, the light goes off. So we did that with the grade 6 PL. The other side is actually using a potentiometer. And the reason I like showing this example is because a lot of students and teachers will ask me, what's the difference between digital and analog? So digital is basically, there's 2 positions, is either on or off. There's no in between. Analog, the example that I have here on the right, that's basically like you have a little dial that you can increase the intensity of your LED brightness. And basically what I have here, I have the 2 sets of code that I have here, and hopefully we can go into this and look at this particular example and see that what the code actually looks like. So right now on pin 0, I have my LED and it's going to ground. So the code, if I want to see, I can actually now, because I have programmable components, click on the code editor. And right here, it's super useful. It's telling you what microbit are you looking at. I'm looking at, I can click on it. I can just click on this microbit and see that that's the code that's associated with this microbit. If I want to see the code that's associated with my analog example, I would just click on that. And then the code changes over here to the example for this microbit itself. Super useful. You could have multiple components here, multiple microbits, and you can code them all separately, which is very useful in that case. You can take your code right here, and you can download it as a hex file so that you can take that code then and download it onto your actual microbit itself, or take it into MakeCode, which is the platform that is often used to program microbit. So I'm just going to close the code editor here and just click on Start Simulation. So if I start the simulation, you will notice that these little things here pop up because there's different sensors on the microbit. There is a temperature sensor. So if our code involved temperature, I could actually alter the temperature just by going up and down with the slider. Our code didn't have anything to do with temperature. There's also a brightness sensor here, so we could actually measure light levels. And these are your different shake options because there's an accelerometer. The code that we have in this example doesn't have any of those, but if it did, we could mimic or simulate any of those options over here. The code that I have, if I go back here, the code that I have for this one right here, I'm going to click on it. When I hit button A, so when I hit button A, it's going to set that pin 0 to high, which basically means the light's going to go on. And when I hit button B, it should turn off, and it does. The code that I have for this one, which is my analog example, is going to plot a graph. As I click on, so this here is my potentiometer, which is just like a speaker dial. You know, you turn up the music, you turn down the music. So you have varying sound levels. In this case, we're going to have various brightness levels. So if I take it now, I'm just going to rotate it around. You'll see that the brightness of that green LED is getting brighter and brighter. And as I actually get to the max, it's going to tell me that it's going to blow the actual LED. In reality, I know experimentally it won't, but I guess they're just erring on the side of caution there. So they would like for me to push a resistor right here as well. And I can easily do that because if I want it, I can edit any of the things that I have here. I would just need to stop my simulation, come over, then close the code editor, go back to my components, and I'm going to put a resistor in. So I'm going to here, and you'll notice I'm going to, right now it's 1 kilo ohm. If I change this to 100, you will see that the coloring on the actual is interesting. The coloring on my resistor changes. The coloring indicates basically you read it, you read the bands, and it tells you what your resistance value is. But some courses I know do that. Other courses probably don't. But all I'm going to do now is connect this, and I'm going to make these green, black. And now when I actually start my simulation, and I actually click on my potentiometer, my dial, and actually go to the max, is not telling me now that it's going to blow. So that is basically a lot of the things that you can do here. Now, with the code, this is very new because it wasn't like this last week. You can look at the blocks. You can actually choose to go blocks and text. Now, when you're looking at the microbit and you're looking at the text, it's Python code, and it actually tells you first line. Anything that is followed here by that like kind of number sign is just basically a comment, and they're telling you it is code that is done in the language done in Python. Now, if you actually come down here and you want to go to text, it actually will say to you, are you sure you're going to lose your blocks if you do this? So I'll just click on it. Are you sure you're going to go to text? You're going to lose any of your blocks. So I'm just going to cancel that. So that's an option as well. If you have any issues with your code, there's a little debugger here that will basically, if there is issues, it'll pop up and say that there's issues, and it'll tell you what line there's issues. So if anybody was interested in that. So the beauty is, I'm just going to go back to blocks. You can look at your block-based coding, You can look at it blocks and text or just text alone, and you can download this as a hex file. That is the file format compatible with your microbit, and just you can program your microbit and from here, really truly. Any questions? And everything else is the same. Here's your components list. So if you click on your components list, it's telling you everything that you need. Now, some students might get a little bit too in depth and say, I need a blue microbit. That doesn't matter. Blue, red microbit, it's all the same.
Christine, did you want to pull out from the components list and just show how you pull out the microbit and just connect the wires? Just if
Sure.
folks want to do that alongside you. Same as the simple circuit, but if you folks want to build a microbit circuit along with Christine, just try it out.
If you want to do it from scratch, we can use the basic raw, but if you actually want to see something that's already started, you can go down here to microbit, click on that, and all of these options are available to you. So for instance, you're like, I really would like to be able to do, I don't know, like this one right here, that is a motion sensor that sets off an alarm. If you want to see how a motion sensor is hooked up to a microbit, you can easily just take that and drag it over as well. And you will see how it is connected. And it's very, very nice that way as well. That's if you wanted to actually, that's actually if you wanted to start, I guess, from a starter that they have. Now, if you want, I'm just gonna lay that over there. If you wanted to start from scratch, you would go back to your basic components, pull out your microbit, and you just drag and drop your microbit, drag and drop there. Now, if I want, I'm just going to hook up the LED light. Going to take it, I'm going to rotate it. So you can rotate it either up right here or just using your quick keys of R. I rotate it around. I'm going to bring in a resistor, change it, or you can just leave it as default there if you want. And then what you're doing is you're actually just hovering over pin 0, it pops up and shows you, when it actually shows up like that as P0 with that red square, that means you can click on it and you will automatically be allowed, or a wire will automatically appear. And that's what you have. And if you want, you change its color. And again, it's important that you hook up your LED correctly. So I have it all right here now. If I want to program this microbit, I've got a lot of microbits here, but if I want to program this microbit, I would just click on that microbit, go to the code. Now, these two are always here. If you don't want those, you would just bring your code down to the trash can and drop it. Now, I want to basically, of this one right here, of this particular microbit right here, when I press button A, I'm going to have the light come on. I'm going to digital write the pin 0 and have the light come on. And when I press button B, I'm going to have it turn off. So this is the microbit I want to code. Click on code, go to my input. On button A, I'm going to, what was that? I think it was this, was it? I can never find this because it's right here, digital write pin. So it's on pin 0, we're going to turn it to high. And then when we press button B, so I go back again and I would take the exact same things. I can just click on it and duplicate it if I want, or go and try to find it again. But when I press button B, change that, I'm going to set the pin, digital write the pin, turn it off. Now, that's the code that I have. I just did for this one, start simulation. You can start the simulation and it will appear on all of these, but I just coded this one. If I press button A, it should turn on, and it does, as you can see. If I press button B, it should turn off, and it does. So you can have multiple programmable components here, and there would be absolutely no problem. You would just click on whatever one that you want to be able to program. Or, like I said, you could have just took something that was already developed and said, hey, how did they hook that up? I can start simulation on it. How can I change the code? How can I change that to make it different to suit the needs of what I'm looking for?
And Christine, you mentioned when you were showing this to me that the blocks for the coding part are similar to that of Microbit and Scratch, but there are some slight differences. But if you have any experience with coding with Scratch or coding for Microbit, you'll be able to figure it out. The categories and the colors are a little bit different. Some of the blocks, the wording is a little bit different.
Yeah, for
but
instance,
more or less the same.
Yeah, like I think if I'm not mistaken, in MakeCode, this one here, digital right pin, you'll either set it to 0 or 1. 0 meaning low, 1 meaning high. In this case, basically they're giving you two options. They're saying low or high. But in MakeCode, it would be either 0 or 1. You're only given two options. So there is some slight differences here, but nothing too major. Now, like I said, with the Microbit, they are updating a lot of things here. So there might be some things that you would expect to see in your block-based coding here, but you may not see it. You're like, hey, that's in MakeCode, but not here. My understanding is that they are updating it and getting this a little bit more up to date with a lot of those parameters.
All right. Any questions on bringing in the Microbit in the simulation? There's nothing in the chat there. And can you simulate a makey?
Can you simulate? No, yeah, not in Tinkercad yet. They don't have that there. But so far as the Microbit and just the oh my God,
The Arduino?
The Arduino. I was going to call it Adafruit, but it's not Arduino. Yeah, that's the only two things that are there in the Tinkercad circuits. And like I said, if at this point in time, this is all you really wanted to know about, like, don't feel bad. Feel free to take off or whatever. I know everybody's time is certainly valuable. I know it's almost 4:30. I was hoping to be able to get to Arduino. Maybe I can give 2 minutes to it. And I certainly won't be able to give it the time that it deserves, but in this, I have some Microbit resources. There's all kinds of lessons. There's all kinds of things that are out there, both on Instructables, because Instructables is close partner with Tinkercad. So there's a lot of starters out there on Tinkercad that you can just use and go with as well. So I'll have those in the presentation. So Arduino, we actually have some for Arduino. I have a lot of Arduinos here. It's just basically it's a step up, I want to say, from the Microbit. That's as simple as we're going to keep it right now. And it's still a microcontroller. Actually, it's a circuit board with a microcontroller on it, but that's not a big deal. So basically, you can also program this with blocks, and you can program it with text-based coding. It doesn't use Python. It's based on another language, which is called C++. And there's so many different I guess, forms of this. There's generic ones out there, like the red one that you see on screen. I think that's Spark Plus. They have like a generic Arduino that you can buy. There's so many things out there. This was developed back in 2005 over in Italy for like, I think it was a fashion design school. And they wanted to have all different aspects, I guess, with respect to fashion and, different wearable components. So that's how sort of this came about. And it's like 20 bucks, I think, just for this board. Super expensive, inexpensive, huge community out there, hobbyists, makers, everybody. There's like a really large community here using this. And a lot of the features, I'm not going to get really into anything here. There's 3 grounds, doesn't matter which one you use. When I talked about digital pins, digital being either on or off, there's the digital pins on top, and your analog pins, that means, varying degrees, like the brightness of the LED that we showed, around the bottom. And it does run on, it's got a voltage regulator, so it does run on 5 volts, but I think it can handle more than that, I think up to 12 volts. So there's a voltage regulator on it that makes sure that your circuit board is not getting fried. So I'm not really going to talk too much about that. Let's create. So basically, right here, I have an example, and I didn't use a breadboard or anything. All I did was use the LED, use the resistor again, and here was my block-based coding that I did. All I said was, I have my resistor, as you can see, is on pin 3. So all the pins here, this is a digital pin, is on pin 3. So all I'm saying is set it to high, wait, and then set it to low. And here's my ground. So all I did on this one, once you look at it, It's going to look different than the microbit, obviously, but in this case here, oh, I just totally made it a lot smaller. If I look at the code in block base, that was all my code. There's no input or output. There's nothing like that with respect to, say, the Arduino. Once you basically are just, basically turning on or turning off one of these pins here, as you can see with the code, and it makes sort of sense when you look at the text, because this code here is based on C++. You're setting up your pins here, and anything else underneath here, void loop. Basically, all that means is anything that happens underneath that is continuous. So this will continuously have the light turn on, off. And you need not even look at the text if you don't want to. You can just have it all in the block-based coding if that's where you want to start. Now, if I look at and start my simulation, you will notice that this is turning on, waiting a second, turning off. So it's a very easy way to start. It is, I guess, a step up from the microbit. It does have, like I said, it runs on 5 volts, so it would be better if any, you have components that are needing that extra bit of power there. So it's really, really useful. And I do have some of these, which we're going to give away today if anybody was interested. And because I think I have, I don't know, I have 20 or so here, and several of them have never been opened. Yeah, so we'll have them as a prize giveaway. So I know this was really quick with respect to the Arduino, but even though it looks intimidating, it's not. It's still got the same thing. It's still got pins like the microbit. It just looks slightly different. So, and there's all kinds of lessons here on Tinkercad. So I'm just going to click on this really quickly so you can look at it, because if this is intimidating, these are all the lessons. If you want to learn how to use the Arduino, this one right here, very simple. Blink your LED. It goes through step by step. This is what you do. This is what you would like bring out onto your board. And once you got it done, and once you got it simulated, it actually goes through. Now, wouldn't you want to test this out on your actual physical Arduino? And it gives you step-by-step directions of how to do that, which is pretty interesting. And as you progress through the lessons, it'll get a little bit more complex, but these are, sequential. I would start off with this one, blink an LED with a digital output, like I just showed you, and progress from there. So you can certainly see how everything develops. So I'll throw it over to you, Megan, if there's any questions or anything like that.
Awesome. So we're gonna go ahead and do a prize draw now. I know there a couple people had to go. Christine, a few people saying in the chat how informative, how great the session was. So so glad that this has been useful for you folks. And like I said, there was a varying degree of people's expertise here, grade levels and whatnot. So I'm glad that people are taking something away from it, and hopefully it's applicable to you and your teaching. We have a few prizes to give away. So we're going to give away a $25 gift card to Amazon. And we're going to give away, how many Arduinos do you think we'll give away?
I'd say we can do 4.
4? Okay. So I'm going to go ahead and present my screen. And you have to be here to claim your prize. So I'm just going to go pull up the wheel of names here. So you just let us know in the chat if you're still around. And I'll jot those names down. And we'll make sure we get those to you. So we'll draw for the $25 Amazon gift card first. Spin the wheel.
And if anybody needs any help or wants to ask anything, certainly get in contact with me, and I'm available to help.
Is Scott still here? Right in the chat. Yes, awesome,
Here.
Scott. So you'll be getting a $25 Amazon gift card, and I'll send that to the email address that you signed up with in the Google form. Awesome. All right, so now we'll do a draw for 4 Arduino.
And there's a lot of students out there for their passion projects, Genius Hour projects, whatever it's called in the schools. They're using Arduinos for a lot of the things that they're doing. So is that Krista Newman?
Kristen? Yeah, awesome. So Kristen gets an Arduino. Who else?
I'm surprised nobody asked me what's the difference between Arduino and Raspberry Pi.
That was the first thing I asked. Crystal. Is Crystal here?
I don't see any. Oh, she's here.
Oh, yep. Okay, Crystal. We'll get an Arduino to you. Okay, and another one.
Let's do 5.
5, sure. Is James here? Don't
Nope,
see
I
them
think
yet.
so.
Oh, okay, we'll do another one. Roger's here. Yeah. Okay,
Yes.
awesome. Okay, we'll do 2 more. Angela? Angela's here, yep. Awesome. And 1 more. Cynthia?
Cynthia is there. Yep.
Oh, you're awesome. Wicked. Well, congratulations, folks. We'll get you those Arduinos. I'll send you an email now shortly to get your preferred mailing address. And thanks so much for coming. Like I said earlier, we appreciate you taking time out of your busy schedules to learn something new. Your students are definitely very, very lucky to have you as their teachers. Take care and enjoy the rest of the school year. And again, if you have any questions at all, please feel free to reach out to myself or Christine.
For sure. Perfect. Thank you so much, everybody.
I'm just going to stop recording there now.
Got